Good afternoon, everyone.
Yeah, good afternoon, sir.
Good afternoon to all of
Good
you.
afternoon, sir.
And
Good afternoon, sir.
welcome all of you to this 5 days faculty development program jointly organized by the KL deemed to be University, KL University, Vadeshram, Guntur District, Andhra Pradesh, and XLR on data science and chat GPT. Firstly, on behalf of KL deemed to be University, I extend a warm welcome to all the teaching fraternity members across the country who have taken efforts to join this program, which shows their zeal and interest and the importance. It also gives good focus towards the importance of the topic of this faculty development program, that is data science and chat GPT. We at KL University strongly believe on upskilling the faculty members of this university on the latest trends and technologies of not only the industry but also on the education field. And this data science and chat GPT are the two domains which, once integrated with each other, will be disrupting a lot of present day activities which we, the teaching fraternity members, are deploying our efforts and our focus, right from preparing the course materials, PowerPoint presentations, or drafting of research articles for publications, or even for getting some data from various sources to analyze and prepare a report or analyze and publish a paper. So this disruptive technology of chat GPT is going to be there with us even if we like or not like, but this is one of the technologies which is going to be here with us hereafter. So we have to learn and upskill ourselves to keep ourselves abreast with this technology and use it for the best of our requirements of fulfilling the academic needs of our students, research needs of our individual self, as well as on the front of developing latest what we say curriculum requirements and course structures, which after this workshop you will be able to develop, so for the benefit of your students of your institutions from where you are joining and attending this program. Almost all 1000 plus 1500 plus faculty members across the country are have registered and will be attending this program. Due to the limitation of Zoom, which is limiting its participants to be 1000, there is also a live streaming link provided from the YouTube. So the learners and the participants can also join through the YouTube link and view the sessions and post their questions there itself, which will be posted here by the host of this meeting. Initially, I would like to introduce this program and thank XLR Solutions to have come forward and trusted the responsibility to KL University to host this event for the best requirements of academic endeavors of the faculty members of the state of Andhra Pradesh as well as country of India. And I thank Mr. Ram Tava, who is the Chief Executive Officer, CEO of XLR Solutions, Mr. Srinivas Reddy, the Director of Products of XLR, and they will be taking you through along with lot many other speakers who are going to speak and make you aware of this technology and also make you perform some hands-on exercises so that you will be able to develop the technology of data science using chat GPT. So these 5 days of program are split into 5 sessions, where in the first session you will be having the introduction to data science, which includes various types of data, that is structured and unstructured data, use cases, basics of statistics, etc. And you will have the introduction to machine learning on second day using the supervised and unsupervised learning linear regression models. And on third day, you will be having the logistic regression. Fourth day will be spent on introduction to the neural networks. And fifth day will be on the transformer models of chat GPT. So this is going to give you a wonderful opportunity to learn and upgrade yourself with the required skills of data science using the chat GPT. So before we proceed ahead, I would like to welcome our Honorable Vice Chancellor, Professor G. Parthasarathi Verma Garu, the VC of KL deemed to be University, to enlighten us and deliver his inaugural message and formally inaugurate this session. Over to you, Honorable VC, sir.
Very good afternoon to all of you. Very good afternoon to all of you, and it's indeed pleasure to have the workshop on this data science and chat GPT. Really, this is the need of the hour. Industry recently, around 3 months back, chat GPT was introduced, and it was really doing wonders actually in this process. And it is important that actually upgrading our skills in chat GPT and how best we can utilize this into the process. So in that connect, we asked the team to work out a workshop for all the faculty and all the members, the faculty fraternity all over Andhra Pradesh and Telangana also. In that connect, most of the students most of the faculty was registered into this. I'm happy that actually all of them are utilizing it. And definitely, this is, once Google has come, people, there are a lot of different opinions actually. When Google has come, actually, there are a lot of different opinions has happened. But ultimately, after Google has arrived, everyone now habituated to Google itself, and now you are taking it. Now, when ChatGPT came actually into the activity, now a lot of things are, a lot of comments are coming up. Let us take it in a positive direction. Actually, now in our hands, AI is going to come, and how best to utilize it is important. And basically, when you Google it, actually, what happens? You have a lot of vast of data, and to read that, actually, we lose interest, we lose focus, we lose a lot of time actually out there. When it comes to ChatGPT, it consolidates all this, and finally, whatever format you want actually, and the comparisons you want, that is going to present in this place. So data science and AI is moved to this direction. Definitely, there are future, evolutions will also come up, ChatGPT and also Google bots, and there are a lot of things is going to come in future also. And as a skilled persons, we should upgrade our technology towards whatever is the latest in the market. Let's have a session at this place, and I'm very happy that actually the XLR is taking care of this activity, and let's have hands-on on ChatGPT and data science at this place, and enjoy this 5-day workshop. And I expect a good takeaways from this workshops, and definitely all of us will benefit out of this. And thanks for giving me this opportunity. Thank you very much.
Thank you, sir. Thank you very much, sir. Wonderful inaugural message and very appropriate. So we have the resource person, Mr. T. Anjanelu, who is the senior data scientist from Spiceworks, Ziff Davis. Also, so before we go with the session, I would like to request Mr. Ram Tava to just brief the session.
Thank you very much, Srinath sir, and it's a great message from Honorable Vice Chancellor GPS Verma. Right. So I'm the CEO of XLR Solutions, and I don't want to take away much of your time. As most of you are well familiar with XLR Solutions, because we have been conducting these faculty development programs, student development programs through various government entities and colleges for the last 3 years. And close to 600 plus colleges, they got registered for this EDL program, Everyday Learning Program. And close to 2.5 lakh students registered for these free courses, and 30,000 faculty pan-India have registered for these courses. So primarily we deal with state-of-the-art technologies like data science, artificial intelligence, IoT. We deal with some conventional technologies, but mostly our niche, and we are specialized in this space, right? And our headquarters is in Houston, and India. We are present in 4 cities across India: Bangalore, Hyderabad, Pune, and Mumbai. right? And coming to this course, I'm very excited that we have been pivoting this course alongside with KL University, being that now it's a buzz, right? It's a buzz that's around ChatGPT. So everyone is keen to understand the disruption what ChatGPT can bring into the industry, and what kind of use cases we can build around this. So everyone is excited. So, and I reckon ChatGPT now, as you see, as we speak, whatever the ChatGPT have been seeing, it is only just the beginning, right? It's only the beginning. The disruption, what it is going to bring in the future, right? It's only time can tell. The way I see it with my 25 years of experience in IT, right? I see this would be a game changer in industry. I still remember 20 years back, if not more, when internet was introduced. So no one assumed that internet is going to be such a big game changer in the modern era. So I would draw parallel lines with internet. The ChatGPT would be analogous to that. Yeah. So I don't find any reason why it should not be a driving force and a game changer in the industry. So it's very, very imperative that the faculty should know about this ChatGPT and should know it's not about the exposure. You should also gain the expertise, right? It does a world of good for you being a faculty when you're teaching the students. And if you want to explore this ChatGPT to the core, right now, prompt engineering is becoming very popular in the space of ChatGPT, right? So I'm very glad that KL University, they came with us in order to conduct this course. I really appreciate their initiative. I know KL University is always ahead of the curve when it comes to the embracing the new technologies. And even this time they have done the same. Even earlier also, we traveled a bit with KL University earlier. Even otherwise, I know about KL University. It's a great initiative, sir. And I thank you both for taking this initiative and taking this forward. And I don't want to eat away much of your time. I know you'll be very excited to understand the nitty-gritties and expertise of ChatGPT. Thank you. Thank you very much, sir. Thank you all.
Thank you, Mr. Ram, for the wonderful introduction. And yes, definitely, XLR is a very good partner and associate for KL University, and we look forward to many, many more endeavors along with you in the future.
Sure.
And you have been doing a very good work on this everyday learning program in collaboration with the APSSDC in the state of Andhra Pradesh. And we were lucky enough to be a part of many of those programs, to co-host that and also to attend those programs organized by you, and they were very useful for the.
Thank you, sir. Thank you. Thank you so much. That's so nice, sir.
And next we have Mr. Srinivas Reddy, the Director of Products of XLR. I request you to enlighten us with your kind words.
Yeah, hello, sir. Thank you. All right. So hello, everyone. Very good afternoon. A warm welcome to the program that we are conducting on the data science and the ChatGPT in collaboration with KL University. So before that, Honorable BC, Dr. Parthasarathi sir, and Dean Skill Development, Srinivas sir, right? And so all the faculty members who are attending this session. Right? So congratulations to one and all, so that we are going to learn an exciting technology, right? The data science and also the industry buzz, that is a ChatGPT, right? And we can say that, so without this ChatGPT, no one can escape, right? So without using this ChatGPT services, so that's how actually the ChatGPT has disrupted the industry now, right? So many activities can be automated using this ChatGPT now. So we want to learn how we can leverage this ChatGPT. What are the use cases we can build on top of this? So without learning that, so we cannot move ahead. So that is the thought process. So we have introduced this ChatGPT. So as part of this FDP program, along with the data science technologies, right? And as part of this FDP program, so it's not only the theory of faculty members, we also have planned a few hands-on sessions. So that is where actually we have been focusing on from the beginning. See, mere theory will not help us, right? So when we practice, so when we understand the nitty-gritties of the practical applications of a technology or a concept, that is where actually we can understand that, yes, I know the concept, then only we can teach to our students, right? So that is where we can do the justice to our profession. So that is where we have been implementing this, the practical applications of the concepts. So that is where, so this FDP also we are focusing on that. So for every concept, let's say be it linear regression or logistic regression or introduction to neural network that we are going to cover, So every concept comes with a hands-on session with a data set, right? So we have a wonderful faculty. The industry expert, Mr. Anjanil, resource person, he has carried a lot of experience in the industry. So he's part of the implementation of these technologies for several clients. He's going to share his experience and also the implementation aspect of the technologies as well as the challenges in the real time. So when we implement these technologies, what are the challenges that we're going to face? So that is where the faculty members can enrich their knowledge from his experience, right? Yeah. So I wish everyone all the very best and happy learning. Thank you all.
Thank you, Mr. Srinivas Reddy. Wonderful message. So now, without further delay, and thanking our Honorable Vice Chancellor, Professor Verma sir, and Mr. Ram Tava and Mr. Srinivas Reddy to have spared your valuable time to join this inaugural session and enlighten all the participants. So now we will go to the resource person of today, Mr. Anjanelu, and I hand over the session to Mr. Harsha, the Associate Dean of Skill Development of Kale University, and Mr. Anjanelu for the further proceedings. Thank you.
Hi everyone, this is Anjanelu, as sir introduced already. Basically, to talk a little bit about myself, I am a mechanical engineer and then I'm a marine engineer. Slowly I changed my career and turned into a data scientist. Now, like from past 9 years, I'm into this field. I've been working on multiple data sciences projects and multiple types of data. It might be structured, it might be unstructured data. It can be just data analysis part, model building part, deployment part. So, I mean, end-to-end data science lifecycle things I have already implemented. I am so happy that XLR has given me a chance that I could kind of share my knowledge and get knowledge from all of you guys across the state. And I see a huge number that has been joined. It's almost 900 plus. I think it will reach 1,000 in some time, I guess. This is the first time I'm seeing so many people joined on one bridge of Zoom and trying to enrich their knowledge. This tells the interest that people are showing in this course, and I'm so happy for being here with you all guys. Right. So yeah, so I have been into training from past 6-7 years now. I've been doing classroom trainings, online trainings, corporate trainings, and also I've done trainings abroad so far. And yeah, so that's a small introduction about myself. And I would really thank everyone who has given me a chance over here. Let's not delay much. I'll just start off with yeah, so just 1 second, guys. I have Leela over here. Can Leela let us know like how to use this LMS? And then from there, I think I can take it off.
Thank you, Anjanelu. Hello, everyone. Very good afternoon. And I'm Leela from ExcelR Solutions, working as an LMS administrator here. Now I'm here to give you an overview of our LMS functionality. LMS is nothing but our XLR's e-learning portal, where we facilitate you all the session recordings, including the live sessions access and the materials that gonna use by our trainer in the sessions. So before I start my presentation, I would like to confirm with you all whether you have received 2 emails from XLR stating that that LMS access has been given to you. The first email says that welcome to XLR and verify your account. And the second one is welcome to the classroom access that has been given to you. So those whoever register for this program using the XLR's registration link would already have received those 2 emails. If not, I would request those whoever not received, kindly register yourself today. So by tomorrow's the session time, we will be giving you the access. And now, yes, I will show you the ways how you can set the password if you haven't done earlier. And then I will show you how you can join the live sessions and how you can access the recordings that are available in LMS. And one more thing, this LMS recordings will be available to you for the lifetime. There is no tenure that they're gonna expire. You can access the XLR training recordings for the lifetime related to this particular program, that is Data Science and ChatGPT International Faculty Development Program. Okay. Yeah, my team member has already shared the registration link. If you haven't registered earlier, kindly use this link and register yourself for this program so that we will give you LMS access by tomorrow. Okay. Yeah. And I'm quickly sharing my screen and explain you the things. Yes. So team, I would request everyone follow the steps that I'm explaining now. You can use any of the web browser available in your device, maybe in the phone and laptop, and type onlinelearning.xlr.com, which is our XLR's e-learning portal URL. As soon as you search for this URL, the web page would appear on your screen like this, as you all can see on my screen, which has 3 options on the top right. So now we have to consider the sign in option. If I click on sign in, it will ask me to enter the registered email ID and the password. So I request everyone to use the registered email ID for the one which you used to register for this program. And then if you have already set the password, you can enter it. If not, you all can try clicking on the forget your password option and type the registered email ID. And you may click on this reset my password. It will send you an email to reset the password to the LMS. You all can try this by your own. If you face any difficulties, you can let us know in the chat, or else you can write us an email to edl@xlr.com. Our technical team will resolve it. Okay. So now I'm trying to log into the LMS using my credentials. As soon as I entered my password and the registered email ID, I would be able to log into the LMS. Okay, so the LMS interface would appear on your screen like this, under which you have many options available, including home, my library, and store. I request everyone to ignore the other classroom access that I have. For today, we have to consider this data science and ChatGPT FDP day 1. So now I'm explaining about the live session joining every day. So you all can use the Zoom link that has been shared with you to join the rest 4 days FDP program as you used today, or else you can log into the LMS under home tab. As you all can see on my screen, there is a today's session tab available on my right hand side of the screen. So under this, you will see an option to join every day at 2:45 itself. The session is scheduled for 3 p.m. but you will have an access 15 minutes early to join the session. So this is how you can join the live session after coming to the LMS every day for the next 4 days of this FDP program. This is the first way of joining the session. In case if you see that the Zoom limit is over, if it is not allowing you in, then you can go to the XLR's YouTube channel and you can view the live happening there. And also our team training coordinators will share you the YouTube link daily, and you can use that YouTube link in case if you are unable to join the Zoom meeting. And these are the 2 available options. Either you can join from the Zoom if it is available. If not, if the limit is over, then you can join the YouTube live happening parallelly. Okay, so yeah, you all can see the access of this classroom. Just a second. Yes, this is the one. Data Science and ChatGPT International Faculty Development Program. I believe everyone would already receive this classroom access. If not, kindly let us know in the chat window. We will try to give it. Or else, there is another way. You can use the registration link and register yourself again. We will give you the access by tomorrow. So this is the classroom, and if I enter into the classroom, I will see 2 available options here. One is curriculum and the second one is Meet. Under curriculum, we will avail all the features, which are session recordings of this particular program, and then the materials which gonna use by our trainer. For now, we already have uploaded, no, not uploaded. It is embedded. The live which is happening now, you can see from LMS also. If you click on this session recordings, it will open the live happening here. In case if you are unable to join the YouTube live also, other than the Zoom application, you can come to the LMS and watch the live happening here from LMS. And this will also available for future purpose as a recording. So this is how you can access the recordings from LMS. And the last option is materials. So here you will see all the materials available in LMS, and mainly these are PDFs that are available. It may not be downloaded to your device. It is accessible from LMS itself. Maybe you can use all the features available like zoom in and zoom out. You may go for full screen, or you can straightly jump into the slide which you require. This way you can access the PDFs that are available in LMS. This cannot be downloaded to your device. If there are any practice files like Python code or some other, if our trainer wants to share it with you, we will make them downloadable. You can click on downloadable option available. If there are any, then it will be downloaded to your device, but not the PDFs. So this is the PDF for today's session. For tomorrow, what our topics gonna taken care of, then we will upload the materials likewise. And the same for every day, you will see the recording available in your LMS. And the last but not the least, like this is the feedback and attendance response. Here is a Google form link. So in order to get the participation certificate of this program, everyone has to fill this form. And this form is available from 4:30 p.m. to 5:30 p.m. every day from today to next Friday. Sorry, this Friday, these 5 days. And when you come to the LMS at 4:30, you can see this link active and you can fill out the form. This helps us to see the feedback from your side, and also we consider that you have attended the session, and we will give you the participation certificate of this program from ExcelR Solutions. So thank you, team. We are very delighted to have you here, and I'm very sure that our trainer, Mr. Anjaneyulu, can make these sessions more interactive. And I would like to wish you very all the best all, and thank you so much. Thank you, Anjaneyulu. Over to you.
Thanks, Leela. Thanks for the detailed explanation. Let's get into the content. Will not waste much time here and there. So today, as we have already shared the details on the topics that we are going to cover, today it's going to be an introduction to the data science industry, I would say, and then we'll try to talk about some applications and then see like what are the kinds of data that we actually deal with. And then try to put some base, right? So for tomorrow's class, so tomorrow we'll be starting off with actual algorithms, starting off with machine learning algorithm like linear regression, and then we'll move on to logistic regression, and then we'll get into some more advanced topics such as neural networks, and then we'll go back to the last, which was ChatGPT, right? So we'll talk about transformer models and then how those are the base models for building a ChatGPT application. We'll talk about all of those things, right? So let me share my screen and let me know if you guys are able to see my screen. Give me a moment. Okay, is my screen visible to everyone?
Yes, we can see. We can see.
Awesome. Thank you. Thanks for the confirmation. So yeah, guys, so this is going to be data science using Python. So why Python? This is one of the most used language nowadays. There are two languages usually people use for model building. One is R and the other one is Python. R is more of a statistical tool, which is, again, there is a support for machine learning applications as well. But nowadays you can see that there are a lot of people who are using Python, and there is a lot of community support also on the Python. That's the reason we have taken this as primary tool to build all our applications, right? So I'll be talking about an application, or I'll be talking about algorithm which can be used, and then from there what we'll also do is we'll try to implement the same algorithm in Python as well. Yeah, Priyanka, any question? I see a raised hand there. Okay. Oh yeah, so I think that's a confirmation for screen. Yeah, so yeah, guys, let's get into the actual topic today. So let's try to define what this data science means actually, right? So can anybody just let me know, like, what are your thoughts, or what are your ideas when you think of this terminology which is called as data science nowadays? Anyone? No answers? Advanced form of AI. Shadab Siddiqui says advanced form of AI. Close enough. AI is kind of, again, a subset in data science. I would say data science is a very big field which will have a lot of other things, AI included as a component in that. Shadab. Any other answers, guys? Guys, you can type in if you want to say something in the chat. I'll open my chat window and I'll be able to see all of your messages here. So the bookish definition for data science says that data science is a generation of actionable knowledge directly from huge amounts of data or of complex data. The goal of data science is to gain insights and knowledge from any type of data, both structured and unstructured. Right. So this is the bookish definition, right? So, but when you talk about how data science is actually perceived in industry is, we want to try to get some sort of insights, or we want to make use of the data that we are already having in any industry, right? So that is called as data science. We want to understand our data very well and also make sure that the historical data that we have already stored will make some sort of a sense to increase our business. So at the end of the day, this is all about trying to get some good insights from the data and making sure that that insight is helpful for us to improve our business and take some business decisions at the end of the day, right? So that is, yeah, that's right, Dr. Murli, right? So decision making for the data. Basically, this is what we want to do using data, right? And now, when we talk about this data, there are again multiple types of data which we will actually have to know, right? So the first thing which we want to understand is something called as structured data, right? So there are two types of data on a high level which we deal with. One is called as structured data, other one is called as unstructured data. And there is one more section which is also called as semi-structured data. That is also fine, but we will try to focus more on structured and unstructured data, because at the end of the day, we want to build ourselves, or we want to make ourselves comfortable to understand the ChatGPT aspect of it. So we want to understand this unstructured data in a better way. We'll start with structured data. Right? So what do you think this structured data means? Anyone? Yeah, so a lot of people have given the answers over here, right? So structured data here means that if I can have any kind of data which can be stored in a certain way, preferably a tabular format, right? So if I have a specific schema associated to my data, that means if I have certain number of rows and certain number of columns in my data, then this can be called as structured data. Right. So now examples, right? So when we talk about structured data, this is how it looks like. Basically, any tabular data, which you can see over here, which has certain number of columns and certain number of rows. Here we have some sort of a university data, right? So there is ID, there is first name, last name, email ID, year of birth, and maybe n number of other fields as well, right? So when we have a column which has a meaning to it, and then we also have number of rows, this can be defined as structured data, right? So any Excel file, any CSV file, any RDBMS databases where you can actually store your structured data, these are all the residences of where you can actually store your data, right? So all of the data which can be defined in this format, which is called as a tabular format, is called structured data. Right. So as I said, your CSV file, comma separated value file, where we are going to use some of these kinds of files, load in our Python, and then try to build models. In our practical sessions, we will see how it can be loaded and how it can be done. Right. But ideally, what I want to say here is any data which can be stored in rows and columns is called as structured data. Right. Do we have any questions over here? Okay. So the next thing is unstructured data, right? So now, as you can see here, anything which doesn't fall in this what you call space of structured data, we can call it as unstructured data, right? So now, examples being any text data, examples being any image data or a video data or sensory data or any text data, everything falls under this category, which is called as unstructured data, right? So yes, Dr. Murli, that's correct. Chat messages like Facebook, Twitter posts, your images, satellite imagery, recordings, right? Your phone recordings or your WhatsApp messages, everything which cannot be stored in rows and columns, we call it as unstructured data. Right? So now, to deal with these kinds of data, we have certain methodology, right? So we deal with structured data in a certain method. We deal with unstructured data in a certain method, right? So again, we will be talking about multiple terminology here. Like we will try to define what is machine learning. We'll try to understand what is deep learning and all that stuff. So yeah, so these are all the things that we will be dealing with, and you will get comfortable with all of this terminology by the end of all of these sessions, I would assure you. Dr. Jagdish, yes, video surveillance data is also called as unstructured data. Any video data is called as unstructured data. That's right. Right. So now let's get into this need for data science. Before getting into even need for data science, I would ask one question. Why do you think there is so much of hype for this data science nowadays? Why not like maybe 15, 20 years ago? Now, why suddenly now? Can anybody just let me know their thoughts on this? If you all see, probably like maybe 10 years or 2010, 12 for my time frame, I guess. That's the time frame when all of these buzzwords came into light and people wanted to do data science and all that stuff, right? So, but sorry, why suddenly now? Sorry. Dr. Jagdish says bulk on WhatsApp or Facebook usage exponentially hiked. Correct. Lots of available digital content as data is growing enormously, right? So Amrita, that's correct. Huge accumulation of data and growing businesses need improved businesses, etc. Right? That's true. So all of the answers are correct over here, right? So there was a burst in data like past 10, 12 years ago, right? So there was the buzz term that we usually talk about was this big data or Hadoop technology that took place, right? So when this happened, we all came to know that the storage of data became very, very cheap, right? So now when we were actually learning, or when we actually bought our first computers, probably they were like 40 GB capacity or maybe 80 GB capacity, and that was too costly for us then itself, right? So now, but now you can see that there are a lot of options. You can store data in cloud. You can have multiple data sources where you can store, and that too on a very cheap price, right? So there are a lot of startups which directly just talk to AWS or GCP cloud, and then they hire some of the space, and then they start storing their data because that is very cheap nowadays, right? So the first thing that is very important for all of us to know the historical importance is that data became, or the storage of the data is very, very cheap nowadays, right? So that's the reason any company who wants to work with, they can store the data as much as they want. And once they have the data, they want to analyze the data also, right? It's not the idea just to store the data here, right? So we also want to understand the data. We also want to gain some insights of the data, like what our definition of data science itself said, right? And make sure that whatever the knowledge that we have taken from the historical or the past data we are having, and see if it is actually helpful for our business to grow, right? So to take some important business decisions, right? So now that is the main idea over here, right? So that was one thing, which was your storage part, right? So what do you think what do you think which is the other wing which actually helped people to probably get into this data science field, or hype this data science field so much? Any answers? One, I completely agree, which is storage became cheap. Internet made a huge data traffic. I completely agree. So this all traffics again will come into the storage thing only, right? Increasing e-commerce, agree. So while we are thinking of all of things, high bandwidth, that is also right? So now we can see that while we are talking about all of these things, one very, very important aspect that which we don't usually talk about is the computation power, right? So now, as you can see, once we had our first systems, probably 4 GB RAM or maybe 8 GB RAM was very, very big thing for us, right? So, but now you can see that I can just go and hire some sort of big CPU or maybe big GPU where I can actually train my models, right? So the computation has also become very, very cheap. And hence you can see that people are trying to get into this as much as possible and trying to make sure that they are using these kinds of technology as much as possible, right? So these are the two important things that we need to understand. One is about the storage and the other one is your computation, right? Computational speed, correct? So these are the two things which are very, very important that we want to remember, right? So this was this was the kind of background, or this was the kind of history that this emerging data science field has, right? So the need for data science, as you can see, as I said already, imagine you are a data scientist of small retail store that captures sales products of 10 MB generated every day. But what happens if these keep on increasing, right? So I want to actually make use of all the historical data that I'm having and try to gain some sort of insights from it, which make sure that this will help for me to maximize my profits or improve my business in multiple ways, right? So when we get into the use cases, all of these things become much, much more clearer, right? But at the end of the day, what we have to understand, it's all about business. We want to improve that business as much as possible when it is in terms of commercial side. But when it is also in the research side, people want to get a lot of these things, right? So one section of applications are these images, this text data, where we want to build some sort of image recognition models, where we want to build the sentiment analysis models and all that stuff, right? So all of these started because there is a need for this data science. So yeah, so here you can see that business has increased further and opened many stores. You can see that the data now is basically in TVs everywhere. And then I want to make sure that I am using all of this data and then building some good applications or building some good models and then try to get all the insights as much as possible. So before we get into the next, or before we move forward, do we have any questions over here? Okay, I assume that things are clearer up till now. So yeah, so data, why all the excitement? We will talk about a lot about this data in these 4 days, basically, right? So what all the benefits? Kavita, can you make this question a little bit more elaborated way? I did not understand this. Difference between big data and data science. Yeah, we will talk about that, Kumar sir, once we understand a little bit more about what machine learning is, and then it will be a lot easy for everybody to understand the distinction between big data and data science. I'll address this question for sure. Yeah. So yeah, so now you can see that this slide says that welcome to the information age, drowning in data and starving for knowledge, so many things, right? So now just imagine how many things are actually going on all around, right? So now, as you can see in this slide, there is the first image that is talking about transactional data, right? So now here, this is some sort of a bank transaction, probably a credit card transaction that is happening around. And then we also want to make sure that if there are any anomalies that are actually happening in this credit card transactions, right? So can I actually build some sort of a model which will analyze or which will tell me if the transaction that has happened is some sort of a fraud transaction or not, right? So if I'm able to do that, probably I'll be benefiting my customer, right? So if I do that, I'll be saving him by by actually saving a lot of money, right? So this is one application that where data science is used very broadly, right? So this credit card fraud transaction, right? So the second one you can see over here is, can anybody tell me what is the second one over here? I'm pretty sure that everybody understands this. Only thing is like the image is a little bit more exploded view. Everything is actually combined in a car itself nowadays. Autonomous car, exactly, Dr. Jagdish, correct. Right, so now you can see that everywhere, or I think probably last 6 months ago, or even now, people talk a lot about this autonomous cars or self-driving cars, as they say. Right, so now if I want to build these kind of an application, just try to understand what are all the IOs that I'll have to do, right? So what are all the inputs and outputs that I'll have to do, right? So if a car has to move from place A to place B, what are the things that it has to evaluate? Right, so what is the shortest path? What is the safest path? I need to understand the road. I need to understand what is in front of me. I need to understand what is behind me. Right, so what is the speed that I need to maintain so that the drive is comfortable? And also, I have to make sure that at every second or at every millisecond, I need to send the signals to the server to give the position of my location and whatnot. Right, so this is the complexity that all of these technologies are used. Right, so this is one very ideal example or application that we can talk about, which is your autonomous cars. Right, so other than that, you can see that this data science is used in stock prediction stuff. Basically, if somebody wants to use any modeling, and a lot of models are helping people to predict whether whether there is going to be a profit or loss in this stock market business. Other than that, you can see that there is a lot of IoT which is over there. The smartwatches. This second one here, you can see in the last row, this is called as market basket analysis, where I want to make sure that I improve my retail business, mostly related to the retail business. And apart from this, in the last slide or the last image, you can see that this is all about your social media, right? So there is a lot of data which is actually getting generated every minute or every second, I would say, right? So if so much of data is actually getting generated, I want to also make sure that all of the data which I have already there with me, I need to make use of it. Right, so that's the reason all of these technologies come into picture, or all of these people who are data scientists, data analysts, data engineers, all of these people come into picture, and then one person tries to analyze the data properly, or one person tries to handle the data properly. We call them as data engineers. One person tries to analyze the data. We call them data analysts. And the other person wants to do some predictions on the data or to build some predictive models on the data. We call them as data scientists, right? So these roles may be overlapping here and there, but at the end of the day, we all want to play with the data and make sure that this data is used somewhere which is going to benefit, right? So yeah, before moving forward, any questions? Personalization as per user preference. Yeah, Chaitanya, that is also an application that people usually use, profiling basically. Any questions, guys? Okay. Yeah, I see this data volatile. Dr. Jagdish, can you elaborate the question? I did not understand whether it's a statement or a question. Couldn't understand that. Sorry. Yeah, so this is one very, very important slide, and you can see that this is not a very new slide. This is taken from 2019-2020 timeframe, but how the data is generated every 60 seconds. Right, so that is one very, very important thing that we all have to remember. Right, so now we can see these are all, not all, probably 80-90% of them are all your social media platforms, and some of them are your e-commerce business platforms. And now just try to look into this pie chart, right? So basically we call this as a pie chart, where we have sections in the circle, and then we try to get the information in some sort of visualization. Here you can see that around 1 million logins are actually happening every minute in Facebook. 18.1 million text messages are getting circulated on your text chat, or maybe this is WeChat, right? And then you can see there are so many 4.5 million videos are getting viewed on your YouTube, and so on and so forth, right? So this is the world that we are living right now, right? So there is a lot of social media transaction that is actually happening. Anybody can actually generate any sorts of data and then upload it wherever they want to, right? So if you just click a small image, put it in Instagram, you're actually adding to the ocean of data, right? So if you just do a small video, some personal video, or some video that you see and upload it in YouTube, again, you're actually generating data, right? So that's how data is getting generated everywhere. right? So that is one very, very important thing that we all have to understand, that this is going to be immersed in a lot of data in the future, and hence trying to understand this data, or at least trying to understand the concept and see how this technology works, becomes very, very important for all of us. Yeah, so there was one more graph which I wanted to show. Yeah, this is the graph that I wanted to show, right? So now we can see over here, this is taken from this statista.com, the reference website. And the data or the graph here, we can see that there is an x-axis and there is a y-axis over here. In your x-axis, you can see we have categories like your years, 2010, 11, 12, up to 2025, basically a little bit of extrapolation that has been done. And in your y-axis, we are trying to give you a kind of thought of how the data is getting generated in terms of numbers, right? So you can see here, the data that is being represented over here is in zettabytes, right? So it's not in GB or it's not in your petabytes. So basically it's a zettabytes. It's equivalent to 1 trillion gigabytes, right? So for the sake of the study, and zettabyte is equivalent to 250 billion DVDs, right? So you can think 250 billion DVDs, right? So this is the amount of data that is actually getting generated every year, right? So in 2010, there was hardly any data. You can just see that 2 zettabytes of data available around the world, and then 2011 more than double, 2012 again increased. Now you can see that the data is actually increasing exponentially everywhere, right? So examples being already discussed, or maybe your social media, maybe your startups culture, or maybe your transactional data that is actually increasing every day, maybe your digital transaction that is having a imprint or a footprint everywhere that is getting accumulated. That's how data is getting generated, right? So now you can see that probably in 2025, in just maybe 2 years, 3 years time from now, you will see around 175 zettabytes of data, which is going to be available all around the world, right? So, and when we are talking in this much volume, we also have to understand, if we have so much of data, what are we going to do with that so much of data, right? So probably we want to see, and it's not only about data science I'm trying to talk over here, right? So handling of data becomes very, very important. Data engineering becomes very, very important because it's in huge amount of data, right? So trying to understand the pipelines, how to build the pipeline around becomes very, very important, right? So, and then once you have the data, understanding or trying to write some basic queries on the data to get basic understanding of the data becomes very important. And at the end of the day, probably trying to build models to get the insights of the data also becomes very, very important. Right. So this is the amount of data, or this is the volume of data that we are talking about. Right. So it's a huge amount of data. Any questions here? No? Okay. So this is one slide which we usually show to our students, basically, right? So this is the salary trends. You can see based on the work experience, people are earning a lot nowadays, at least in this field, I would say. There is a lot of huge, exponential earning that is actually happening in all the companies that you can see, right? So anyway, this slide, I'll be putting it in the LMS. You can look into this slide and try to understand and make some relationships, so salary versus work experience, and see like how this is different from other fields. Right. So let's get into the most important stuff right now, right? So applications of data science, right? So can anybody explain me like what is actually happening in this slide? What does this product recommendation means? Anyone? Alexa, the Alexa is different, sir. It's not like relevant to this slide. Yeah, this is a recommender system. I agree. Wireless mouse, that's true. This is a machine learning application. So the point that I want to make over here is what is actually happening while you're trying to do some sort of shopping, right? So I'm pretty sure that everybody in this class, we have done online shopping, right? So when we know that we have already done online shoppings, you can see that there is a lot of activity that is actually happening on your screen, right? So for example, if you're buying one sort of a mouse, there would be a lot of other sorts of mouse which are actually recommended to you, right? So how is this happening, right? Or why this should happen for now, right? So similarly, if you're actually buying some sort of laptop, let's say, you will see that there would be similar products which will be suggested, maybe which are better or maybe which are easy for you to compare, which gives a user experience for a person to buy, or else maybe they are trying to increase their business as well, right? So now, for example, if you try to buy a laptop for, let's say, right? So if you're trying to buy it, you can see that there would be some sort of mouse or maybe some sort of laptop bags and all that stuff, which is actually recommended to you, right? So if that is recommended to you, why do they have to do, or how it is done, right? So how it is done is again a different technical part, which probably I'll not get into. But the application that I want you all to understand here is, this is a sort of business, this is a sort of algorithm that all of the e-commerce business have implemented, right? So now what they usually do is, they try to give either a user experience, to give that, or to give a sense that they have so many options that are available on their site, and then probably you might want to look into all of those things and then buy, which will give you a user experience, and probably you will stay with that website, maybe Amazon, Flipkart, whatever it is, right? So maybe you will stay with them. Or else, if you have, or if you're trying to buy a laptop and then they are trying to recommend you some sort of a mouse, they also want you to buy a mouse because it might be useful to you, right? So these are all called as recommender systems or recommendation systems. They want to recommend you some sort of what I would say products here, right? So in this example, all of these are products. They want recommendations to be sent to the customer, so that customers has some easy context to buy all of these products, which increases again two things. One, maybe user experience. The other one, maybe the goods with which they are trying to sell as well, right? So this is one very, very important application that you might want to remember, right? So like this, there are like n number of applications as well. So it might be, let me just try to explain all of these things, right? So now you can see here in this slide, you see there is something called as predictive maintenance using machine learning, right? So the goal of predictive maintenance over here is to forecast and prevent component of any equipment. It might not only be the car or something, but I want to understand my machinery itself, right? So let's talk this in terms of a mechanical field over here, right? So if I'm actually maintaining some sort of machinery, for example, a car, I want to understand well before that when it may go into breakdown, right? So if I am able to understand, so for example, let's say that maybe in a month, if my engine is failing, if I know it before itself, maybe I'll send my engine to overhauling before it fails. It will save a lot of money, and probably it will actually save a lot of time for me if it happens, if the breakdown happens when I'm actually in some sort of work while I'm traveling. It is going to be a safety matter also for me, right? So these kinds of decisions can actually be done by using these data science algorithm. It can actually forecast you, it can actually predict so many things from your data itself, right? So you can see here, the first thing says collect. Data gets transferred via telediagnostics or over Wi-Fi. You can see that there might be some sort of device that has been stored in your system, which is actually sending the impulses or the pulses of your engine, or maybe whichever the equipment we are talking about. And if there is some sort of change in the performance, that will be actually noted, right? So you can store it in any data center, then do the predict failures by building algorithms, and then probably you might want to send it into some sort of a repair center before it actually fails, right? So once it has already failed, probably it is not a predictive maintenance, right? So predictive maintenance is, I want to predict before something wrong is going to happen on my what you call equipment over here, right? So do we have any questions over here before we move forward? No? are these predictions stored somewhere? Yes, Chaitanya, we will be storing all of these predictions in some sort of cloud or maybe in your local as well, right? So all of these predictions are very, very important. Yeah, CSV is just a file format. Maybe we will be storing CSV also. Any other questions? Okay. Yeah, so now let's try to understand the complete workflow, or I would say I usually refer this to as complete life cycle of a data science project, right? So we'll try to understand this first and then try to get into some more stuff, right? So this is very, very important for all of us to understand. Before that, I have some messages. Let me just check. I hope for all sort of equipments only. Need predictions require more exercise on data sets. Yes, Dr. Jagdish, that actually there is kind of a formula, I would say, how your predictions are going to matter, right? So when you have a lot of data, probably your models are trained in a better way and then they give better predictions, right? So that's the reason we urge for a lot of data from our clients or for whatever the application that we are working for. Right. So now let's get into this part, which is called as workflow from data to decisions, or I would simply call it as a data science lifecycle. Right. So let's not get into this flowchart that we are having right now. I'll try to draw something for you, and then we'll see if it is understood or not. Right. So whenever we are actually trying to build some sort of model, or if a client comes to you and says that I have so and so problem statement and I want solution to it. Right. So what are the steps that we usually follow? Right. So the first step that we want to follow, or the first step that we want to know is, do we have enough understanding of the problem itself? Interested in model training, but like to hear from you how these models are built. Are we going to build basic models or we will be using paid one? Chaitanya, we will be building models in our classes. So tomorrow probably we'll build our first model. Yeah. Right. So the first step that I wanted to talk about was understanding the problem statement. Right. So this is one of the very, very important steps, right? So most of the times, whenever a client comes to you and tries to explain the problem, there are so many scenarios that the developer or the project owner or whoever is actually handling the project, they usually are kind of a disconnect in the problem understanding itself. The client wants something and we try to understand something and we try to build the model or we try to implement the solution even before we are having the complete knowledge on the problem statement itself. So that's the reason this becomes very, very important. You will probably need to have so many calls with your client to make sure that everything that has been explained from the client side about the problem statement is understood completely from your side as well. So that's the first step, right? So now in understanding of the problem statement, what are the different steps, right? So probably you might want to understand what domain this problem belongs to, right? So when we are talking about this data science, this data science field is not a domain specific field, right? So today probably you might be working on a telecom industry problem statement. Maybe next month you will be working on some sort of a retail domain problem statement. After that, probably you'll be working on some sort of a medical domain problem statements, right? So you will be working on n number of problem statements, because whenever we are talking about any kind of data or any kind of domain for that, right? So there will be data, and if there is data, there would be somebody who is going to work on that data, right? So that's the reason this data science is not domain specific. You might be working on some sort of a mechanical industry. You might be working on a medical industry. You might be working on even educational industries. Anything is possible, right? So that's the reason you will probably need enough amount of research that you want to do once you hear the problem statement, right? So that is called as your literature survey. right? So I want to make sure that I have understood the problem first. That became your first step, which is understanding the problem statement itself. The second thing that you want to look into is the literature survey. That means, are there any papers or are there any research that has been already been done on this problem statement? Right. So can you please share the topic of 5-day session so that if anybody wants to understand fully, do some research on these topics, right? Yeah, so I will be, I think this was already explained in the beginning also, but before I close the session, I'll be talking about that as well. What are the things that are going to be taught? So literature survey, as I was saying, basically trying to understand if there is some sort of a historical solution or if there is anything that has been worked upon, right? So because I don't want to assume that this problem has not been solved by anyone else before and started from beginning, right? So maybe I want to start it now itself, or maybe I want to see if there is any solution that has been already been implemented and want to build my solution from there, right? So that's the reason this literature survey becomes very, very important. This literature survey will not only give your understanding about the previous ways of handling it, but it also tells you that what are the variables that they might have been used in their data set, right? So are you missing those variables in the present data set, so that you can say that, okay, maybe if some important variables, so variables here are called columns, right? So whenever we talk about variables or features or your X variables or your columns, all are same over here. We'll be using the terms interchangeably, right? So now you can see that the when you do this kinds of survey or when you do this kinds of literature survey, you'll also try to understand what were the variables or what were the features that people had already used. And you try to connect, saying that, okay, am I also having these features because these sound pretty important, right? And then probably I want to get into the problem statement itself, right? And then the third step, can anybody try to guess what would be the third step after understanding the problem? Analyze the data, correct? But before that, Dr. Jagdish, getting the data itself is a big task, right? So how do I get the data, right? So trying to actually acquire the data, right? So data acquisition becomes your third step. Right? So now this data might have been stored in multiple, what you call tables, right? So you might, collection of the data, right? So that becomes very, very important, right? So you can see that data can be stored in multiple sources, right? So understanding the sources, trying to bridge all of those sources, probably trying to understand how to pull the data from different servers, or maybe pull the data from different data lakes or data things. Basically, that becomes very, very important, right? So data acquisition is also one of the important stuff that you all have to understand, right? So maybe there are multiple data or multiple tables which you may want to relate one to other and then pull. There might be some common key which is actually trying to have information about some other data frame as well, right? So maybe that is the case, right? So trying to understand that relationship between your data sets itself, or maybe your tables itself, becomes very, very important. And once you have that in your mind, or when you understand that data, and then you can pull the data and start working on it, right? So once you have this data acquisition done, that means once you have your data on your local or maybe on the server that you're working on, what are the other things that you may want to do? Anyone? So now you have your data with you. What do you want to do? Methods of data collection, that's true, sir. We have already collected the data now. Once we have the data with us, right? Now what? Build methodology, that's true. Structure it. So yeah, structure, understand the data. Tarun says understand the data, that's true. Analyzing the data, data normalization. Yeah. So basically what you want to do is you want to try and understand the data as much as possible, right? So once you have your data with you, there are certain important steps that we follow in our data science life cycle to understand the data as much as possible, right? So now maybe I have the data set with me, and probably this is some sort of a tabular data. I have variables x1, x2, x3 up to xn. Maybe I have row 1, row 2, row 3 up to row m, right? So now I have my m into n data set with me, right? So now once I have my data, I want to make sure that I have understood this data as much as possible. Right? So how do I want to understand the data? Probably I want to understand the dynamics of the data first, right? So maybe the first thing that I want to do is shape of the data. Shape of the data is nothing but the dimension, basically. How many number of rows are there and how many number of columns are there, right? So this gives me the first thing, that how big a data is that I am working with. Is it a very small data? Maybe like in your medical domain or something like that, usually you will have very less data, maybe 1,000 rows, 2,000 rows, maybe 5,000 rows. Is it some sort of transactional data? If it is a transactional data, you will have rows in millions, right? So now that will give you a sense of how big a data set you are having. And that also defines you what would be your next steps, right? So once I have understood the shape of the data, probably I want to understand the data types itself, right? So what does this data types mean? Anybody? So when we talk about this data types, we want to understand basically whether this type of the data is some sort of a numerical data or maybe categorical data. Right? So this will tell me how or what kind of columns do I have. Right? So it might be a numerical data or it might be a categorical data, right? So again, in this, there would be ratios that people talk about, right? So there are again, multiple things, but on a high level, we want to distinguish our data in these two terminologies. One, we call it as a numerical, and the other one we call it as a categorical data, right? So what does a numerical data mean? Again, in this numerical data, we define data into two types. One, we call it as continuous. Other one is discrete. Right, so these two things form under or fall under this numerical data. And in categorical, again, there is something called as nominal data or nominal categorical, and then we have something called as ordinal. Right, so we will try to understand all of these terminologies when we actually get into the pre-processing of the data. But on a high level, this is how our data looks, and these are all the pointers which tell me how I want to work with my data. Right, and then once we have all of this understanding, right, so how many columns do I have, how many rows do I have, and in those columns, how many numerical columns are there, how many categorical columns are there. Based on that, I may want to do something else also, right? So now that third step, we usually call it as data typecasting. What does this data typecasting mean? Anyone? Basically, exactly, Dr. Jagdish, right? So basically what happens here is we want to try and convert our data into a specific format. Maybe your tool, maybe you are using Python or R or any other tool, it has interpreted a categorical variable into a numerical variable just because of the numbers that it has. Or maybe there is a numerical variable which has got interpreted in terms of a categorical variable because there is a string present due to some mistake. Right? These are all the steps of data cleaning, right? So you want to make sure that you clean the data as much as possible, right? So there would be a set of steps, all of that beginning from your data types itself. So we all call this as data pre-processing. Right? So we want to clean the data as much as possible and make sure that all of this data is good enough so that we can use this data to build our model, right? So even in this, after data typecasting, probably what I want to do is maybe I want to check for null values. Everybody understands what are null values? Right, so there might be some sort of a missing values in my data, right? So you can't expect that your data is going to be completely full with all of the data which you require, right? So there might be some of the missing values, there might be some empty strings, or there might be some NA values in the data, right? So if there are any NA values in my data, how would I deal with that, right? So there are multiple methods. Maybe I can go with some sort of imputation methods, or maybe I can go with some sort of methods where I can drop the data itself and so on and so forth, right? So that is one method how we want to clean up the data, right? So the other thing that probably you want to check is one very, very important concept, which is called as outliers. What are outliers? Anyone? Extreme values. Yes, Madhu, right? So basically any point or any value which doesn't belong to the present distribution of the data that I'm having, then we call it as outliers. Noise is also correct, right? So all of this noise also can be called as your data outliers in the data, right? So something which doesn't belong to your distribution of data itself, somewhere far, far away from your distribution when you try to draw a histogram, right? So then we call it as basically a outlier, right? So this is how we identify our outliers, and again dealing with these outliers is also very, very important, right? So there are again certain steps that people usually follow. Maybe they want to delete, or they want to get rid of the outliers that they are having. If there are a lot of data points, ignoring those rows itself makes sense, right? So but if you have less values, or if you have less what you call number of data points, then probably you might want to deal it within in a different way. There are methods like clipping and all that stuff that usually statisticians do to make sure that they don't lose data, right? So these are some of the steps that we might want to do while cleaning our data, right? So has anybody questions or anything that you want to share or discuss here at this point of a time? No? Okay. So once we have all the data which had to be cleaned properly, right? So once we have that done, the next step that we want to do is something called as standardization, or sometimes we also do something called as normalization. Right? So what does the standardization or normalization mean? Right? So we want to make sure that all of the data points or all of the columns that we are having are able to relate to each other. That means just because of the intensity of the values, we don't want to assign more importance to it. Right? So maybe I have a column called as age, and then I have a column called as a salary. Right? You can see that the intensities of these numbers which we are going to have is going to differ a lot, because probably your salaries will be in 4 digits or 5 digits or maybe 6, 7 digits. Age will be hardly in 1 or 2 digits, right? So even you will not find a 3-digit age, right? So it's very hard to find those things also, right? So just because this intensity of the value is less, you can't assign less importance to this column itself, right? So usually what happens is in your models, based on the values of those models, your model will start assigning the importances for the variables itself, right? So hence, to avoid such things, what we do is we try to standardize our data or normalize our data, right? So what does standardization mean? Usually we want to bring all our data into a distribution which looks something like this, which is a normal distribution, and have all the data points, the values will be between -3 to +3. Right. So again, there is a little bit of theory behind it. Why -3 to +3? We have a rule that 99.9% of data stays in between -3 to +3 standard deviations and all that stuff. But ideally, what do we want is we want to standardize the data, having relative values between the columns itself. Right. So when we do a standardization of the data, it implements a formula. It implements something called as x minus mu by sigma. Mu being the mean of the column, sigma being the standard deviation of the column, and x being the value of what you want to standardize with. Right. So when you put that in this formula, you will get a value will be somewhere near between -3 to +3. Right. So this is what is expected. And if it is too much high or too much less, we can call them as outliers there also. Right. So basically, we want to standardize the data with this formula. We can do this or also we can do something called as normalization, right? What does this normalization mean? Normalization is nothing but trying to again squash your values between a range of 0 and 1, right? So we usually use a formula like x minus x min divided by max minus min. This is a formula that we use, right? So given a column, we identify what is the maximum value, we identify what is the minimum value and put it over here, and then put it over here, and then take each and every value, do a subtraction and get whatever value, and that will be a new age underscore 1 or maybe age normalized value, right? So we'll try to get that done in our Python as well, right? So this is basically your standardization or a normalization method, right? So you can use either of that. People usually try with multiple things and then settle with either standardization or normalization. This is all again experimentation, right? So there is no set of rules that you can't say that I'll only use this, I'll only use that. It's all again experimentation. Sometimes you might get good results with standardization. Sometimes you might get good results with normalization also, right? So those are your data standardization or normalization techniques, right? So apart from all of these things, we also do something called as feature engineering. Let me clear this up and start with a new, right? So there is something also called as feature engineering. What does this feature engineering mean? Anybody? Any thoughts? Analyze features. Okay, that can be a part of feature engineering, but it cannot be the complete feature engineering itself. Selecting appropriate features. Yes, Vipul, that's correct. Feature extraction can also be called, but basically what all the things that you guys are saying over here, selecting appropriate features and feature extraction, these are all feature extraction. But we know there is something called as feature engineering. What does it mean? Acceptance criteria for feature. Okay, so feature engineering is trying to generate new features. Generate new features from existing features, for example, right? So let's say that I have a data set which has refined features, can be called Chaitanya, but trying to generate new features, I would say, specifically, because this example makes things clear, right? So transformation, yes, that's also correct. Now you can see that, for example, I have a column called as date of birth, right? So now this is the existing column for me. Now, if I want to generate a new feature from this feature, which was date of birth, for example, this was in some format, MMDDYY, right? So this was the format. What I can do is I can generate a new feature from this, like age, which will make more sense for me for my analysis rather than having a date of birth, right? So like this, you can come up with a lot of feature engineering techniques where you can use 2 or 3 features, and from those 2-3 features, you can generate new feature, right? So these are all the feature engineering techniques, and these play a very, very important role while you're building the model, because you are actually trying to extract a lot of data which is more relevant for the model to understand or to get the insights from it, or insights from your data, right? So transform raw data into features. Sangeeta, that's also right? So basically you want to do the transformations of your columns in a right format or in a right way, so that your model is getting some help from your end as well, right? So now giving this date of birth column as it is probably doesn't make any sense to the model itself. Hence what I want to do is I'll just try to transform this in some format which model understands. Age would be one very, very useful way to extract data from date of birth, right? So how would I do? Maybe I have a date of birth, and then I will create one more column called as today date, right? So, and then I'll just do a difference of what is the age between today's date and date of birth, and I'll get age in numbers. I can convert that into days, months, or maybe probably years, however it is required, right? So this is how we play with the data, or this is how we want to generate new features from the old features that we are having, right? So this process is called as feature engineering, right? So do we have any questions here, guys? Okay, right. So this was how we want to do all the things, or how we want to do all this. Basically, all the steps that I discussed just now fall in a bigger bracket or a bigger terminology called as EDA. Basically, EDA is nothing but exploratory data analysis. Right. So I want to understand the data as much as possible. I want to make sure that my model also understands my data as much as possible. I do all of these steps and give my data to the model. Right. So at the end of the day, I want to train a model on a very good data, because we usually have this notion while we are building models. Right. So basically, we call it as garbage in. And this is the model probably, and then garbage out. Right. So if your model has to understand this data, you need to remove all the garbage from your data. Then only this model will be able to perform well. Right. So that is the one thing which you always have to make sure. Right. So that's the reason most of the times I would usually people spend around 60 to 70% of the time in all of these what you call steps itself. Right. So to clean the data will take a lot of time. Calling a library, building a model doesn't take much time. It's hardly like 5-10 minutes time for us to build a model, even if it's even if you're having a pretty big data. Right. So nowadays computation is pretty fast. Right. So that's the reason you may want to spend a lot of time, as much as possible, on your data cleaning. And once you've done, or once you're confident on your data, then you go with your model building. Right. The question here is, Kumar asks, limitations of feature engineering. Yeah. So limitation is again based on the creativity that you're having. Right. So there might be some feature engineering methods which will actually work, and maybe there are some feature engineering methods which will not work. Right. So that's the biggest limitation. And there might be nothing that you can usually do on some columns. Right. So this is only something which you have to think and come up with a new strategy and say that, okay, I will do this feature engineering, because this feature engineering which I have done will extract data in a much better manner, and then my model probably does better training on this. Right. So it's all again kind of subjective thing that we might all want to consider. I hope it answers the question. Yeah. So let me clear my screen. So do we have any questions or any doubts until the things that we have covered so far from beginning? Venkateshwaralu, all the structured data follows normal distribution? No, usually not. So you will have to make sure that there are a lot of other distributions as well. The assumption here is we assume that every data that we have is going to follow a normal distribution, but usually there might be a lot of differences also. Right. So to make or to bring that normal, what we usually do is we usually go with these kinds of feature engineering or maybe standardization of the data and all that stuff, and see that our data is at least normal or somewhat relatively normal. Ramesh Kumar asks, is there any tools to perform EDA on raw data? There are multiple tools, Ramesh. There are libraries in Pandas directly where you just give your data to it, and then it will spit out all the required information about your data. But what I would prefer is not to use such tools right now in the beginning phase. Right. So probably you may want your hands to get dirty in the data. Right. So you may want to look into the data, try to understand the data, go into it manually, do whatever the things that you know on your data, and then try to go to that tools which are available in Pandas. Right. So that might help you, but I would not suggest anybody to directly use these kinds of tools on your data, because understanding your data is very, very important. Any other questions? Okay. So the next part, once your data is ready, right? The next part that we usually talk about is called as your model building, right? We want to build our model on the cleaned data and then try to evaluate that model and see how our model is performing, right? So now, even before that, what we usually do is we divide our data into two parts. right? So usually what we call it as, let's say that I have a data. Let's say that I want to predict something, right? So we have not gotten into what is supervised learning, what is unsupervised learning yet, but we will get into it. Let's assume that we already know it, right? So let's say that I have some variables like age, maybe salary, maybe gender, maybe location of a person, and so on and so forth. And now I have customer 1, customer 2, customer 3 up to M customers, and I have rows up to N rows, right? So this is the data set that I'm having right now. Now I want to build a model. Let's say that this data has already been cleaned with all the processes that we have already done, right? So we have done the cleaning of the data, and now this data is ready to build the model or ready for the model building. Now, before we go into that, what we want to do is we want to understand our data, which we have already done. And what we want to do is we want to divide our data into, let's say, 2 parts. One, we call it as training data. And then we have something called as testing data. Right? So if, for example, I have some 1,000 rows in this data, right? So usually what people do is people split it into 70-30 split, or maybe 20-80 split, right? So what do? Is they want to actually train their data, which is a partial data, which is training data, on the model, right? So now with this data, the model learns all the patterns. And now in the next phase, what I want to do is I want to test my data with the testing data and see whether the predictions which my model is doing are correct or not. Right? So does this concept make sense to everyone? Training and testing? Yeah. Right. So now I just don't want to build my model on the complete data I have, because once I deploy it on the server, or maybe once I make it public, or when I put it on the production environment, I'm not really sure how my model is going to perform on unseen data. Right. So that's the reason I don't want to show some part of my data to the model itself. Right. So that's the reason what I will do is I will train my data only on training data and test it on my testing data, and then try to see whether it is actually predicting correctly or not. Right? And then if my model is performing well on the testing data, then only I will put it on prod, or I will put it wherever it is required, because I have certain amount of confidence saying that, okay, my model will do good on unseen data. Does it make sense? Okay, so let's say that Madhav says, let me explain this again, right? So let's say that I have a prediction problem to be solved. I will say that this problem statement is trying to predict whether a customer is loyal customer or non-loyal customer. Right? So this is a classification problem. We'll try to understand what is a classification problem, regression problem, and all that in tomorrow's class. Right? So, but what I'm trying to do is I am trying to predict a customer whether he is loyal or non-loyal. Right? So now, if I want to predict this, I have to build a model on some data. Right? So now I had around 1,000 records. Now what I have done, I have just randomly split my data into 700 and 300. Right? So to answer the sorting, basically we don't sort our data. We usually we shuffle and split it randomly. Right? So now this 700 becomes my training data. What I'll do is I will pass my model, or I will pass my data as a training data to this model. Now this model will have extracted some patterns, or it will have adjustments of its weights based on the data that I have already shown. Right? So this is kind of a feedback loop where it is seeing a record and then looking into the variable, whether it was loyal and non-loyal, and it makes corrections to itself, and it's getting trained. It's just like trying to train a small boy. Right? Once I have done all the training with this 700 records, now I want to test it. How would I test? I would pass these 300 records in the trained model already and get the predictions. Right? So now in this data, I already have my ground truths, which are basically predictions, right? So which are from your client itself. And then I will get predictions from my model, right? So now I can compare my ground truth with predictions and evaluate how my model is doing on unseen data, which is 300. Does it make sense? Okay, right. So once this is done, what I'll do, if whatever the evaluation metric that I am choosing, right? So let's say that I have chosen accuracy as an evaluation metric, right? So we will talk about what accuracy is, what recall is, and everything. Let's say that my model is saying that on your unseen data, which is test data, it is 60% accurate. Then probably I need to do much more on my data. Maybe I need to bring in more data and train it properly. Maybe I have missed some of what you call pre-processing. I have not done some, maybe I'll use some other model, not very simple model. I'll do all of those changes and again retrain my model and again test it. And then now let's say that my model is maybe 85% accurate. Once I see these kinds of good numbers, this gives me confidence that how my model is doing, right? So when this gives me a confidence, then what I can do is I'll say that, okay, on unknown or unseen data, my data is doing good. I'll just pass in I'll just send my model to the prod or maybe whatever the server I'm placing in, because I have my enough confidence. Does this make sense to everybody? I hope it makes sense. Let me clear this. Right, so this is how the training or all the process happens, right? So now you can see that I will acquire some sort of domain knowledge. I'll do some feature engineering, right? I'll get the data from something, get the insights from data itself, right? So by doing all the EDA process, which we talked about. And then once I have done, I give my data to the model itself. Now my model will try to predict, right? So if my predictions are actually acceptable by the business, then what I'll do is I'll send this model and actually deploy it in the product. If there is a feedback saying that, okay, your model needs to be trained much more properly, or maybe it's not performing as it is expected to, that's the feedback that you are going to go get. And then you probably again go back to your data, relook into the data. Maybe you want to add more data, do some other pre-processing stuff, other feature engineering, again, rebuild your model, right? So maybe earlier you had used logistic regression, and then probably this is not giving much result. Hence what you do, maybe you are going to decision trees or maybe random forest. You will use much more complex models and make sure that these predictions are better. And once all of this is good, then you are going to deploy it. So does this make sense? The whole process, the complete life cycle of how your machine learning model is built. Okay, I hope this makes sense, guys. So that was the basically the flow, right? So now you could see that there are multiple tools here to do all the things that we wanted to do, right? So I'll use R or Python to extract features. If I want to get insights, maybe R, Python, and Tableau, because Tableau here is a visualization software. To call in data, maybe I'll use some SQL queries, right? And then to build models, maybe I'll use R, Python, PySpark, or some cloud platforms. And again, same R, Python to do predictions. Once I do the predictions, maybe I want to visualize those predictions in my Tableau or maybe Power BI and all that visualization stuff, and then move ahead, right? So that is how your complete life cycle is built, right? So this is how a data science life cycle looks like, right? So here you see that there are some applications or some tools which are there on your screen. You can see that statistical analysis, data mining, supervised, unsupervised. We have not gotten into supervised and unsupervised yet. Tomorrow we'll talk about it. There is a section of problem statements that we usually solve. It is called as your text mining or NLP problems, which is natural language processing. And then you have your AI, forecasting and survival analyticals and all that stuff, right? And then These are all the tools which people usually use for building, right? So most predominantly what we'll be doing is we'll be using Python in this 4 days, whichever are left, right? So tomorrow we will try to build a model if possible, and then try to implement that on Python and see how the results will look like, right? So that's the one which we'll do in tomorrow's class. Yeah, so this is usually the workflow, trying to understand statistical concepts, trying to understand data mining concepts, to the forecasting, and to make sure that you are like up to the standards. There would be some projects and assignments which you might want to do online on your own and then get it done. Yeah, so yeah, these are all the algorithms that we usually have in Python, or basically in machine learning or in the complete data science, right? So there might be different algorithms for different ways. Just a moment, guys. Sorry, guys, I had to look into something else. Yeah. So these are all the algorithms that are available that people want to do all the model building techniques, validation techniques, and other stuff. Yeah, so this is what I actually plan to cover in this class, guys. We have still maybe 10-15 minutes left, I guess. If you have any questions, I'm very happy to answer. You can just type them in the chat window. We can discuss them. Ammar, are you here?
Yes, I'm there.
Yeah. So yeah,
so team, one information from my side. I already shared the attendance link with you in the chat box. Please mark your attendance.
So it's all the participants, right?
Yes.
Please provide material with workout examples. What's your view on AI and data science? Can you brief the topic? Oh yeah, thanks. I almost forgot, right? So basically the things that we are going to do in the next 4 sessions would be, tomorrow we will try to understand the whole machine learning overview. And then we'll try to understand what is supervised learning, what is unsupervised learning. And then we'll get into a regression problem, which is linear regression. And then we'll try to implement the same problem statement in Python and see how the predictions will look like. Right. So we'll also try to understand some evaluation metrics, like what is RMSE, what is MAP, what is MAE, and all that stuff. Right. So the next day we'll try to understand a classification problem statement, which is logistic regression. On the 4th day, we will look into one advanced topic, which is neural networks. We'll try to understand what these neural networks are, how these neural networks differ from your normal machine learning algorithms. And then on the last day, we'll try to look into the transformer models and try to connect those concepts to the ChatGPT, how they have built it and all. Is data science needed coding? Yeah, Kumar, you will need basic level of coding for data science. Is the division of validation part is also necessary in training? Yeah, Ramesh, that's true. Some people divide the data into 3 parts. Some people divide it into 2 parts. It all depends on in which company you are and how they have put their SOP, right? So the sequence of steps, basically, how they have done. Some people only have 2 sets, some people have 3. What is your views on artificial intelligence and data science? Right. So as I said, guys, so data science is kind of a big ocean. and artificial intelligence is some sort of a subset in that data science, I would say, right? So I'm not looking both in a different way. They're all going hand to hand, right? So they are all going together, I would say. How about people without coding language? So Madhav, even if you don't have any coding background, it's not hard for anybody to learn these languages. Python is a very simple language, just like your English. Only thing is it might need a little bit of practice, I would say, because I would give my own example, right? So as I said, I am a mechanical engineer. I did not do any coding. We hardly had some sessions in our engineering first sem, which is also on C, right? And then after 7-8 years, I switched my career, right? So coding, you will be not doing like assembly type level of coding. You will be doing very basic coding, which is easy for anybody to understand, I would say. Kumar asks Python, R language, or any other. Python, R, maybe SQL a little bit. These are the three which I would recommend anybody to learn. So I hope, guys, this session was useful to everybody. I think it gave, at least I hope it gave a little bit of perspective, like what these kind of, what this actual data science means, right? And I hope to see everybody even in tomorrow's class. It's going to be interesting, all of these 4 sessions coming ahead. Amar, do you have anything at the end to close off? Thanks, Venkateshwarlu. Appreciate it. Thank you, Ramesh. Thank you, everyone. Then thanks for joining. Yeah, Amar, do you have anything to close off?
Just nothing from my side. You're done?
Yes, things are
okay
from my end.
So thank you so much, team, for joining the session. We'll meet you on tomorrow at same time.
Yes. Thank you.
If you're facing any difficulty while accessing the LMS, please drop an email to edl@xlr.com. My team will help you. I'm sharing that mail ID in the chat box. If you don't have any query or question, then you can leave. Team, if you have any query or question, please drop in chat box. I will take it up. Yes, so you will get the recorded sessions, material, and attendance in the LMS, so you can visit. Today's recorded session will be available by tomorrow morning. Okay, I'm sharing the attendance link with all of you guys. Please mark your attendance. Okay. Yes, team, we are going to upload the material in the LMS. Dinesh Chandra, if you are facing difficulties while logging the XLR LMS, so please drop an email. So we'll check your account status from backend. Okay, Dinesh? Nice session. Thank you so much, all of you, for such a valuable feedback. Thank you. How to give my attendance? Okay. Rajendra, I already shared the link with you. I'm sharing with you once again. I hope you received that. Yeah, you need to mark that attendance by Google form. Okay, so there is a question. What is the attendance criteria to get the certificate? So team, 60% attendance is mandatory to get the certificate. How we check the attendance? Once you fill the form, then you will get the notified. Like your response submitted successfully. Team, if you don't have any query or question, you can leave the session. Yes, we'll upload the notes in the LMS as well. Yes, you can. You're welcome, Jyoti. Thank you so much, all of you, for joining the sessions. We'll meet you on tomorrow at 3 o'clock. Password for LMS not accepting, madam. So do one thing, just forget your password. Then you will get one email regarding that. Set your new password and again try for signing. Shadab will check. Shadab, you are done with your registration? when you registered, like today or yesterday or day before yesterday. If you are done your registration by today, then you will get by today end of the day or tomorrow morning. Yeah, then definitely you will get access by tomorrow morning. You're welcome. Yes, Vasha, there is attendance link I'm sharing with you. Please mark your attendance. Couldn't see the material or link session which is live. Priya, you are done with the registration? Yes, Praveen, to submit form is sufficient for attendance. Yes, right. A team, I am sharing attendance link with you. Please mark your attendance. I have registered and verified my mail ID, but couldn't see in the LMS. Priya, do one thing, drop an email to edl@xlr.com. We'll check. Okay. Okay, Praveen. Okay, thank you so much all of you for joining the session. We'll wind up now. Have a nice day.